Well, hello there folks, I hope you're doing well. In this video we're going to be talking about chapter 6.5, Slope. The slope of a line, or a line segment, part of a line, tells you how steep the slope is. The sign of the slope value indicates the direction it goes, whether it's going up and to the right, or up and to the left, or you could say, or down and to the right, whichever, up and to the right and down to the right, or up and to the right and up and to the left. Whichever way you want to put it. The slope is simply the change in the vertical, so the vertical change divided by the horizontal change. That's often written as m, using the variable m, so when you see the variable m in functions, it means the slope. And it's equal to the rise over the run, is how we say it, or m is equal to delta y, which means the change in y, divided by delta x, the change in x. Because it's a ratio, it's generally not expressed with units. There's going to be one exception, but we'll get to that. So, once again, a line that rises from the left to the right has a positive slope. A line that falls from the left to the right has a negative slope. So as the rise goes down as we go forward, it's negative. As if the rise goes up as we go forward, it's positive. When you determine the distance from one point to another along a horizontal line or a vertical line, you can just simply count. So if we're looking between 2 points on a line, A and B, for example, point A is at 3, -2, and point B is at 8, -2. We can just count 3 to 8, that's 5 units, or we can subtract 8 minus 3. The change in the x value is also 5 units. By the same manner, we can do it vertically. If we're going from C, which is 12,2, to D, which is 12, -2, we'll count down. So 1, 2, 3, 4. Well, we're going down 4, so that's -4. Another way that we could do it is going from wow, they have it weird. That's very weird. I guess they have it backwards. I don't know why they have it back in the textbook. Don't worry about it. By subtraction, that would be -2, our ending, minus +2, our beginning, which gives us -4. And you know what? I am going to just plain old change that. So let's change that. The distance CD, well, I guess if we're just doing the distance, yeah. But we don't want to do the distance. We want to actually do -2 minus +2 is equal to -4 units. There you go. Fixed it. Anyway, so if we have the specific case here, if it rises up, and so in this case, I guess that's why they're going that way. It's a little... They've done it a really weird way. So our rise is going from 5 to 8. To go from 5 to 8, we need to add 3. So we could say 8 minus 5 is equal to 3. And then our run is from 1 to 3. 3 minus 1 is 2. If we don't have specific numbers, the rise is always the y2 minus y1, and the run is always going to be x2 minus x1. So we take our second coordinate and subtract the first coordinate from it. That's basically how we do it. So, and obviously, we can't take the same point. So x2 can't equal x1. That's not allowed. That's not allowed. If we look at line AB here, up here once again, so AB, if we do rise minus run, the rise, we go from -2 to -2. -2 minus -2 is equal to 0. So there's no rise. If we look at the run now, we determined from 3 to 8 is 5 units. Why? This whole page is just messed up in the textbook. I think I don't understand what they're going for. Anyway, for the flat line, perhaps this is 2 pages mixed together. No, it's not. I don't know what they're doing. Either way, for a flat line has no rise, so it's 0 divided by the run. 0 divided by anything is 0. So the slope of a horizontal line is 0. For a vertical line, however, our rise is whatever that is, but our run is going to be 0 because it's not going anywhere left or right. However, we're not allowed to divide by 0. So the slope of a horizontal line, a straight line flat, is 0. 0. The slope of a vertical line, a straight line up and down, is undefined because you're dividing by 0 and you're not allowed to divide by 0. Everything else, we just use our slope formula here to figure it out. Let's do some examples. Hopefully that will help. The North Shore in Vancouver, popular place for hiking and biking. Apparently that's where Mr. Sumner goes walking or hiking back when he's at home. Bridges and stunt structures on trails are complex and often extremely challenging. They have a huge variety of slopes. Classify each slope marked on the photographs as either positive or negative. So let's look at these slopes. For A, we are going from A to B. We go up and to the right. If we go up and to the right, it's a positive slope. For C to D, we go down as we go right. If we go down while going right, that's a negative slope. From E to F, once again, we go down and to the right, so it's a negative slope. And that's it. I mean, that's the first part of that right there. So remember, up to the right is positive, down to the right is negative, or however you want to remember it. Let's get into maybe a slightly more complex question. When discussing a roof truss, carpenters refer to the span instead of the width. They talk about the pitch rather than the slope. Determine the pitch of the roof supported by the truss shown. Explain the meaning of your answer. So what we need to do is find out the rise over the run. But if you look at it, it goes up and then goes down. If we tried to find the rise over the run of this whole thing, we would just go from a height of 0 to a height of 0, which would be a slope of 0. But that's not what we care about. We want to know the pitch of the roof. So we want to know the slope of half of the roof. So we'll choose that half there. The height is 10, but the span or the width or the run or however you want to call it is going to be half of 48. So the first thing I want to do is 48 divided by 2. So run is equal to 48 divided by 2, which is 24 feet. With that, I have my rise. I should write that too, just in case. Rise is equal to 10 feet. So now I want to figure out, sorry about that, I want to figure out my pitch. The pitch is another name for slope, so pitch is equal to, sorry, I don't know what's going on with my pen here, slope, which is equal to rise divided by run. My rise is 10 feet. My run is 24 feet, because that's half the span of my truss, which is equal to, well, they say 5 over 12, which I mean is, I guess, an acceptable answer. Kind of a weird way to put it. Or you could say it's equal to 0.417. 4166666 is continuing on forever. Or you could even, since this is a right triangle, you could use the tan ratio of your slope. The whole idea of the slope, it's actually the tan ratio. So like little bonus thing, the angle is equal to the inverse tan of your slope, which in this case is 22.6 degrees. So you might say, and this is bonus right here. So you might say that the pitch of the roof is 5/12, or 5/12, or you could say it's 0.417, or you could say it's 22.6 degrees. Either way, you would be giving the same information in a different way, and either way, you'd be right. And what does that mean? Well, that means that, I guess, yeah, what is the purpose? So this one is nice because it tells us very clearly that for every 12 feet of distance of, I'll say span, the truss rises 5 feet. So there you go. There you go. Let's go on to an additional example. Example number 3. What is the slope of each line segment with the given end points? Well, let's write our first equation. So m is equal to rise over run This thing knows it's the last time I'm using it for Math 10. So it's acting up. Equals rise over run, which is point y2 minus point y1, or the y-coordinate from the second minus the y-coordinate from the first, divided by the x-coordinate of the second minus the x-coordinate of the first. So for question A, we look at, so the y-coordinate at the end of t is 2, minus the y-coordinate at the beginning is 6. And we divide that by the x-coordinate at the end, which is 5, minus the x-coordinate at the end, negative 3. So that gives me 2 minus 6 is negative 4. 5 minus negative 3 is 8. Which simplifies if I divide the top and the bottom by 4, negative 1/2. Or, once again, if my thing wants to cooperate, it doesn't want to cooperate. Sorry about that. Which is the same as negative 0.5. That's the answer for A. For B, we are going to do the same thing. And C as well. In the book, they have it going a different way. This is, I think, the simpler way. This is the only way I will be teaching. If you want to see a different way, check out the book. So once again, it is y2 minus y1 divided by x2 minus x1. So I have my second y-coordinate is 8, and my first y-coordinate is 3. And I divide by my second y-coordinate, which is 4, minus my first y-coordinate, which is also 4. Uh-oh. Well, would you look at that? I have 5 divided by 0. This is a vertical number. I mean line. It's only going straight up and down, so the slope is undefined. There we go. So that is the answer to B. For C, I mean, there's only 2 ways we're going to go just because of how these instruction books go. Either we're going to get a positive slope or we're going to get a slope of 0 because we already have a negative slope and we already have an undefined slope. So let's see which one it is. m is equal to the second y value, which is -7, minus the first y value, which is -7. Well, I guess that answers that. Divided by my second y value, which is -1, minus the first y value. Sorry about this. Let's try that again. The second y value, which is -1, minus the first y value, which is -9. Well, -7 minus -7 is the same as -7 plus 7, which is plain old 0. -1 minus -9 is the same as -1 plus 9, which is 8. And 0 divided by 8 is just like 0 divided by anything. Just plain old 0. And if a slope is 0, that means a line is horizontal. So the line will look something like that in that case. The line will look something like that in the second case. And the line will look something like this in the first case. And that's example number 3. Example number 4 has us use the slope to graph a line. The point -3, 2 is on a line that has a slope of -3/4. List 3 other points on the line and then graph the line. So there are 2 different ways to do this. You can do it just algebraically first and then graph it, or you can make the point on your graph and then find the points that way. The second way is easier, so that's the way that I am going to be showing you. And so I am actually going to change up the page a little bit, add a screen shade so that we don't get distracted, and take it step by step. So the slope of the line gives the rise and the run from one point to another. The first thing I want to do is plot -3, +2. So -3, +2 is this point right here on the line. And you know what, maybe it is easier to see this way. There we go. So -3, +2, that's our first point on the line. That's what I'm going to do. Put it right there. Since the slope is negative, it tells me that I am going to go down 3 points every time I go right 4 points. So I'm going to go down 3 points from my first point there. And let me get the pen out. So I start at -3, 2. I'm going to go down 3 and then over 4. 1, 2, 3, 4. And then I'm going to do the same thing. Go down 3, 1, 2, 3, and go over 4. 1, 2, 3, 4. And both times I'm marking my point. I could do the same. I could go down 3 more and go right 4 more to get a third point, but you can also do the opposite. So if we're going down and to the right, that means we go up and to the left. So I could go up 3 and left 4 and right another point. Either way, I am making a graph that is going to give me a slope of -3/4. And the last thing maybe I want to do is create a line connecting these 2 points, or these 4 points, pardon me. So there we go. It is done. Just make it a little longer. Maybe make it another color. Can I change the color? I can't change the color easily, I guess. That's fine. No. Maybe. Properties. I can change the color. There we go. Red line. Easier to see. Red line made from my 4 original points. There we go. So this line here is a slope of -3/4 because we made it using that slope. That's the benefit of doing it that way. And because it does ask for the actual points, I suppose we should give them the other, or the coordinates of the other points are 1, -1, 5, -4, and -7, +5. And that's it for example number 4. Finally, example number 5, slope as a rate of change. This is the exception that I mentioned was going to happen, where the slope is actually going to have units. The Brentwood Regatta in Mill Bay, BC is the largest junior rowing regatta, whatever the heck that is, hosted by a single school in North America. The races are all 1,500 meters in length. The graph shows the approximate times at the 500 meter mark and the 1,000 meter mark for one of the boys' races. Determine the average rate of change for this portion of the race. Surprise, it's physics. Once again. So we have here the 2 points, 500 meters. They're at 85 seconds and 1,000 meters or a kilometer at 180 seconds. Our time, as always, is our x-axis, our independent variable. Our distance is going to be our responding variable. Well, the slope of our graph is equal to the rate of change we're looking for. Which is equal, in this case, it's still the rise over the run. So our rise is distance. So it's the change in the distance divided by our run is the time, the change in the time. Hey, it's delta D over delta T. Something we've seen before. So that is the same, once again, this is review now, D2 minus D1 divided by T2 minus T1. So my second distance is 1,000 meters. My first known distance is 500 meters, so 1,000 minus 500. My second time is 180 seconds, so I write 180 minus my first time of 85 seconds, which is going to give me 500 meters over 95 seconds, which is kind of useless until you throw it into your calculator and get a more familiar answer, or more familiar units of 5.26 meters per second, which is the velocity. So in a distance time graph, the slope of that graph is the velocity. So slope, in this case, equals the rate of change which is velocity, V. Except they didn't want me. There we go. The velocity, the V. And that's it. That's it for slope. That's it for Chapter 6. That's it for Math 10C, at least this COVID year. In summary, a positive slope goes up and to the right. A negative slope goes down and to the right. A slope of 0 is a horizontal line. An undefined slope is a vertical line. The slope is the ratio of the rise over the run. For any straight line, you can just take 2 points on that line and determine the slope. It's the second y value minus the first y value divided by the second x value minus the first x value. If you've got 2 easy points on the line, you can just count. So if it goes across at certain intersections in your graph, so on your graphing paper, if you have 2 points on different intersections, you can count. You can say, okay, well, it rises up y number of units between them, and it runs X number of units between them, that's my slope. And there you go. And the slope is going to give you the average rate of change, which is our velocity when we're talking about distance over time. And that's about it. Well, I hope that's clear to you. If you have any questions, please do let me know. I hope you have a fantastic day. And I will talk to you later.